Model rocket of Group 29, presented by Lisa Rozoff and her partner, Hunter Schoaf.
We began our design process by first creating a model for our rocket on the OpenRocket software that we learned to use in class. We were able to utilize this model to design fins that were capable of carrying our rocket to the desired altitude of 700 feet. We began building our rocket by first assembling the Estes E9 motor housing.
We then recorded thrust stand data that would tell us the amount of force that the motor put out over a certain amount of time.
OpenRocket actually allowed us to find the exact dimensions of fins we would need for our rocket. We were then able to use these exact dimensions in NX in order to design CAD fins that we were then able to laser cut.
We were then able to use special tools to attach the fins exactly 90 degrees from each other. We then assembled the parachute, which was cut from a garbage bag and attached to a shock cord. The shock cord had one end glued to the body tube and the other tied to the balsa stopper. The nose cone was a plastic egg that would later house the real egg.
Our camera and altimeter were housed in the payload section of our rocket. We used foam to keep them in place during flight. In order to reduce the drag on our rocket, we made sure to cover the hole that we created for the camera with a small amount of film that would allow it to be as smooth as the rest of the rocket.
After this, the rocket was ready to go and prepped on launch day.
You can see in this video clip that our parachute deployment was successful.
3, 2, 1.
Even though the rocket went slightly off course and fairly far into the cornfield, we were able to recover it with an unbroken egg. From the altimeter's data, we can see that we didn't quite reach 700 feet, and our velocity was slightly inconsistent in the first few seconds. We learned from this that it is better to have a stability closer to 2 calibers for a more consistent flight. We also learned that it is very important to plan out the entire rocket before beginning the building process. And during construction, each step must be carried out without mistake, because each mistake creates more error during flight.